In this tutorial, we will learn to define ventilation flows in BISTRA. We shall continue from the project file of the previous tutorial. You can also download the project files related to this tutorial from the link mentioned in the comments. We will add a ventilation flow of 100 air changes per hour inside this cavity. You can also refer to the manual under section B.19 to read more about ventilation flows in BISTRA. In summary, the Physibel color types BC free and BC FRES can be used to create a ventilation flow path. Regardless of whether they are adjacent or not, these colors can interact. The origin of a ventilation flow path can also be BC simple or BC sky. In this example, say we consider forced convection. So for the cavity with color 193, we change the standard to nihil to custom input the convective heat transfer coefficient as 2.5 watts per meter square Kelvin. The depth of the cavity is 0.1 meters, and the height and width are 1 meter. Since the volume of the cavity is 0.1 cubic meter with an air change rate of 100 per hour, we get an air flow of 0.00277 cubic meter per second. Now from the Edit menu, choose Ventilation Flows. Create a new row by clicking on Insert After. Then, from color 170 to color 193, we define the ventilation flow, which is the amount of air flowing from outside to inside the cavity. This is 0.0027. It's not necessary to define the amount of air flowing out from the cavity to outside, as software already considers that the same amount of air which is flowing in would also flow out. Click on Calculate to run the analysis. We can compare this result of temperature inside the cavity with ventilation versus without ventilation. Next, we subdivide the cavity with BC free into 4 parts. The idea behind this is to get 4 different convective nodes, where the air flow passes from node to node. This method is more precise, and we can calculate different temperatures to create a temperature profile within that cavity. Using the bisect icon, we first subdivide the cavity into 2 parts. Then, using bisect again, click on the lower part to further divide it into 2 parts. Similarly, we do the same for the top segment. Now we have split the cavity into 4 parts with colors 193, 197, 195, 196. We will now update this in the ventilation flows, from color 170 to 196, from 196 to 195, from 195 to 197, from 197 to 193, to complete the path. It's important that the flows are the same for all the ventilation flows in this cavity. We will now click on Calculate to run the analysis. Upon completion, open Graphic Output, click on the temperature profile. Here we see varying temperatures along the height within this cavity. We can also add a function for the ventilation flow rates. Create a new function with reference V01. Here we can link to an external file. This is just a text file with a list of numbers which can be linked to the ventilation flow rates. Alternatively, you can also link with a predefined function. Say, for example, a positive sign function. Input the parameters as shown here. To better visualize the function's graph, from the Functions menu choose Y-scale, here choose fixed values and input maximum value as 0.0027. Click on Calculate to run the analysis. We can plot the temperature profile within the cavity for each time step. The ventilation flows in BISTRA are not just limited to air, we can also use them to define any other fluids as well, like water flow, for example. You can read more about this from the Physibel knowledge base document C12 floor heating. Here we wanted to model the heat flow from hot water through these pipes. This is a 3D case, but we analyze it in 2D using a trick by cutting the cross-section at various intervals and then linking the same flow rate to have consistency. Here, it's important to input the density and specific heat of water, as it has the values of air by default. Thank you for watching. See you in the next tutorial.